I've got a lot more questions, but we do have to move along, so I'd like to thank you for that. And now I'm going to turn to Karen Shakespear Koenig. And you also brought a video from SRI, and we're going to look at that video, and then we'll chat. So let's go ahead and see Karen's video from SRI.
Actually a really interesting time in robotics now, because robotics has been around for 40 years, but now it's this age of new robotics where it's becoming much more accessible to the everyday person. You have high school kids that are doing kinds of robotics that my engineers were doing 5 years ago. You could foresee a type of robot where it's not fully autonomous like the stereotypical Rosie from the Jetsons, but where you have a robot that someone could log on to, and you actually have a person that's able to work remotely and to assist somebody in the home.
Our earlier medical telepresence manipulation systems, like the Da Vinci, cost over $1 million today. But systems like the Taurus, developed specifically for the bomb squads, needed to be on the order of $30,000 to be affordable. Other applications in the home, like sorting pills, as you saw earlier, need to have a price point even lower than Taurus. The current generation of mobile telepresence robots can be purchased for only a couple of thousands of dollars.
There's many kinds of applications where we can provide expertise on location at much more economically and ways that make better business sense.
So that was a clip from SRI International's robotics program, and I'm speaking with Karen Shakespear Koenig, who's an integral part of that program. So is the main trend in robotics today to make them cheaper and more accessible to people?
I think one of the biggest hurdles that robotics has run into is that it does cost hundreds of thousands of dollars for a robot that's not really even as capable as a human. And you can hire a human, at minimum wage to do very complex tasks. So in order to break into these new frontiers like the home or interacting with people in a flexible environment, robots really need to be cheaper.
Now, there are really some functions that robots can perform that humans cannot, like robots can work in environments where humans can't. Is SRI working in those areas?
Absolutely. That's a great application of robotics. For example, underwater robotics is a good place to explore, and we have a couple of programs related to that. Also working in hazardous environments. Nate mentioned the DARPA Robotics Challenge. So, for example, if another disaster hit where some, oil rig was compromised, you wouldn't want to send a human into that environment, even if you could possibly avert more disaster by turning off a valve or locating the source of a leak. So that's a great application to send in a robot that can explore that environment and actually make a change that prevents future disaster.
Do robots have to be very complicated, or could you have robots that have simple capabilities and then combine them together, like robots that have good mobility and attach to them robots that have good sensors, so you can kind of mix and match?
Sure, yeah. I think a lot of the development right now, if you look at what is coming out on Kickstarter or other funding platforms, people are adding robotic capabilities to smartphones, and that's a good way to add mobility or manipulators to something that already has a lot of the brains and sensors that you might need for a robot.
Now, when SRI designs something like a robot, does it go into the business of manufacturing the robot, or does it spin off a company and turn that over to private industry?
SRI is a research organization, so we're actually a nonprofit. We do work for commercial companies and governments. And when we make a product, say the Taurus bomb disposal robot, we develop it for our clients, but in order to make it in hundreds of units, they need to take it on and manufacture it themselves. So often our clients will take it on, or if we come up with something on our own, then we spin out a company around that.
Now, SRI has produced surgical robots like the Da Vinci, for example. What's the biggest challenge in developing a robot that is actually going to cut people open and manipulate their inner organs?
So that's a really big challenge in itself. I think interacting with the human body in a medical sense is a very complex problem because you have the potential to do great harm. So ensuring that the robot is reliable and meets all the safety standards is one of the biggest challenges for medical robotics.
Now, is the robot essentially a puppet where there's a human at the control, so the robot doesn't do anything? The robot doesn't say, well, I think I'll make the incision right here.
Yes. Currently, just as you saw Tom controlling the robot in the video, when surgeons operate a robot, they're essentially puppet masters. They're working at a console, they see with the robot's eyes, and they can manipulate the robot's hands.
So what's the advantage of the robot? Does it have like enlarged vision so the surgeon can see more detail and translate his larger movements into smaller robotic movements?
Absolutely. So when we spun out Intuitive Surgical, what they discovered was the really killer app for their surgical robot is working in tight, confined spaces. So a surgeon's hands are a certain size, but when you want to operate in a very small region of the anatomy of the patient, it really helps to have a much smaller manipulator that the surgeon can control, and then the robot scales down those motions to be much more precise where it's interacting with the patient.
Well, I saw in the film the robot was filling pill capsules. So that's pretty fine movement, and those look like little small forceps. I guess for surgery they need to be a lot smaller still.
Sure, that was the Taurus robot, which is maybe a great-great-grandchild of the Da Vinci robot. So once that company spun out, we continued evolving the telepresence technology to control other manipulators that were lower in cost. So the Taurus robot was designed for bomb squads to do the precise motions that might be required to investigate potential bomb threat, maybe opening zippers, examining small containers, and it can do that at a much lower price point.
Now, one question I have is how robots see. I mean, do you need two cameras so you can get depth perception?
Well, there's a lot of different options here. If you have a very defined task where you can predict what the robot might be looking at beforehand, then you might be able to get away with only one camera. But what we've found, mostly for applications where there's a person controlling the robot, it really helps to have the same two eyes that a person has mimicked in the robot, so that you can actually get 3D vision and understand whether you're going to hit something when you move your manipulator.
Is there any prospect of artificial intelligence in robots where the machine is actually making its own decisions?
Yes, I would say that's a great area of research right now. I think what will happen is it will gradually be phased in. Right now, most of the robots are under direct control of the human, so the beam is always being driven by someone. It's not going to wander around on its own and investigate. And eventually, what will happen is that some of those tasks will be automated. So I don't know if they do this yet, but maybe the beam will have a return to home function, so that from anywhere in the office building, the user might be able to say, just get me back to the docking station, charge me up, I'm done. And that might be, that's a pretty easy thing to understand and accept. And little by little, these things they'll become standards. Mm-hmm. And then autonomy will kind of surprise us, I think.
That's fascinating stuff. Well, let me open this up a little bit to everybody, and anybody can answer this. What is really driving robotic development today? Is it the government that's pushing it? Is it big corporations? Is it amateurs working in their garages? And what's the impetus?
Well, it seems to be a little bit of everything that you mentioned. The DARPA Robotics Challenge is one great example of the government getting involved and trying to further robotics. The recent acquisitions by Google from all the robotics companies from Shaft in Tokyo to BDI in Boston, all give this impression that there is going to be a big blossoming of robotics in the commercial space.
I would say it's already had that effect. I think Google effectively scared other companies into beefing up their robotics programs.
So is there a race where nobody wants to be left out and everybody's rushing to get
Essentially.
I'd say prior to Google's acquisitions, though, the other trends, I was working on telepresence devices 4 years ago. 4G did not exist 4 years ago, and we rely heavily on 4G when we want to bring these outside. Also, the entire internet infrastructure is carrying more bandwidth. We can expect that more locations and more people have bandwidth to carry not only the beam, but robotics in general. If we're ever going to have a humanoid in our house, it's going to be requiring a very good internet connection in order to make decisions. The other thing is that components components are just a lot less expensive than they used to be. So more people and more individuals can tinker, and more companies can build prototypes for a lot less money. For example, for smaller consumer robotics, prototypes might be built from 3D printed parts. Well, 3D printed parts are also getting less expensive. And so over the past 5-10 years, components, internet, batteries, chips, and the processing power, all of that is getting less expensive and more powerful.
Last question, because we only have about a minute left. Do you think we're getting to the point, as some people have said, that we'll eventually all have personal robots in our homes, just like we all have personal computers in our homes? And so if you want to drink from the refrigerator, you'll just send your robot and it'll bring it back, and it'll be like your little butler or valet.
Well, I personally believe that robots will start playing a bigger role in our lives, but humans always like to have some sense of control over their environments.
Okay, that's the signal. We've got to wrap. Sorry to say, I have lots more questions, but we're going to have to close. I'd like to thank my guests. Thank you for watching. Visit our website, www.futuretalk.net. For Future Talk, I'm Marty Wasserman, and we'll see you next time. Okay, so that is a wrap. Thank you all very much.